All right, hello everybody. Welcome to an introduction to NSX-T architecture. I'm Andrew Volmer, product manager at VMware, and with me is Dimitri DeSmit, also from the product management team, who will be doing some live demos today. So we prepared this with live demos, so hopefully the demo gods will be with us. So the usual disclaimer, we may talk about some futures in this session. I'll try to specifically point out if we discuss anything that is future, but in general, most of this is functionality that we are delivering today with a new platform called NSX-T, which is an evolution of our networking and security platform. So our vision is to, is it not projecting? Hold on a second. Or lost the screens. We'll have to start over, hang on.
So you need the gods for the demo and the gods for the PPT as well?
Here we are, I got it. Let me start, go back. All right, false start. Okay, so again, I'm Andrew, this is Dimitri, product managers at VMware on NSX, and this is Introduction to NSX-T architecture. Disclaimer slide, futures may be discussed, but I'll try to point out what is future and what is not. So our vision is NSX everywhere, and if you were at the keynote this morning, you saw a slide similar to this that Pat put up on the screen. Today we deliver NSX in on-prem deployments for ESX and into the vSphere environment. We also support with NSX-T KVM deployments, and I'll go a bit more into that in a bit. And our long-term view is to support bare metal as well as Microsoft-based virtualization technologies, all in on-premise data centers. And we do this in three main areas: security, automation, app continuity. These are our three big use cases for NSX that we can deliver this on-prem. The next area where we focus on NSX is in end-user services, whether or not it's mobile device management or VDI desktops. We can protect virtual desktop environments through our microsegmentation with NSX today, and we'll continue to invest in this area in the future. An interesting new area which NSX-T is designed to deliver on is the new app framework or containers world. There are a number of sessions about this at VMworld this year, and we have some slides that'll talk about that. But we are making significant investments into doing networking and security services for container technologies, whether or not it's Docker, Cloud Foundry, or Kubernetes-based environments. And then a big area of investment for NSX-T is Amazon, management of native Amazon components. This is slightly different than what Pat talked about in the keynote. He was talking about VMware on Amazon as a VMware complete vSphere stack. We also have a set of features that allows NSX to manage native Amazon components, the VPC, native Amazon firewall, as well as native Amazon AMI-based workloads. And we'll be extending that to other areas like Google Compute and Microsoft Azure in the future. And then finally, a lot of focus is going into branch office and IoT technologies. We have customers who are retail branch-based stores, and they want to protect those localized store offices and microsegment those to prevent hacks within a retail branch. And then there's the Internet of Things, which is a big emerging area for NSX. So the goal is to produce this new platform called NSX-T to solve all these use cases, to provide NSX everywhere, a global vision of networking and security for both your data center as well as your remote offices in any compute format that you decide you want to use. So for today's agenda, we have a couple areas we're going to go over. We'll talk about the architecture of NSX-T, NSX networking and security services specifically on top of that architecture. We'll talk about management and operation tools, which are critical to running your application successfully with NSX, and then a couple NSX use cases. So we'll start with the NSX architecture. So the way this works is you have your physical infrastructure layer. Now NSX can run on any physical networking infrastructure. All we require is that there's IP connectivity from each of the hosts or hypervisors to each other. This physical infrastructure is agnostic. We're agnostic to whether or not it's Cisco or Juniper or Brocade or HP-based networking equipment. And on top of that, we layer what we call the data plane. Now, the data plane is the packet forwarding engine that sits in the kernel modules of ESX and KVM. And this allows to create an abstracted virtualization layer. In addition to that, we also have the NSX Edge, which is the ability to create connectivity between the virtual environment and the physical environment at both layer 2 and at layer 3. So a robust routing infrastructure as well as a layer 2 bridging. This is all very high performance in NSX-T. We leverage something called the Intel DPDK, the Data Plane Developer Kit, to get line rate performance as high as 40 gig per second per NIC north and south in and out of your cloud environment. On top of that, we have what's called the control plane, and the control plane is a series of NSX controllers, typically 3 of them. They're in a VM form factor, and they program the flows or the data into the data plane. So they keep track of all the flows and configuration settings, and we separate this control plane from the data plane on purpose. And then on top of that, we layer what's called the management plane, and this is the NSX manager. Today it is a single node, and in the future we're working towards a multi-node manager. It's where the graphical user interface runs, as well as a REST-based API as an entry point where the cloud management platforms typically will automate NSX. So on the very top, often customers will run a CMP of some sort, whether it's developed in-house or OpenStack or some other sort of custom-based cloud management solution. We also have customers who use things like Ansible or Puppet or Chef or Terraform to automate the process of deploying NSX itself for installations, as well as network topologies. So you can do continuous development, continuous deployment, continuous integration with NSX through our robust REST API. So let's talk a bit more how this would work. So again, the same 3 layers. We have the manager, the central control plane, and on the actual different transport nodes, which are either our edge gateways or hypervisors, we have a local control plane. So there's a daemon running on each control plane where we can program in flows from the central control plane. And if you're familiar with NSX for vSphere, which is the other product that we've been shipping for a number of years, this is a slightly different architecture. It's much more distributed to allow for the CCP and the local control plane to be separate from each other. So the way this works is a user will make a desired state configuration. Maybe they want a certain network topology, certain firewall rules, certain load balancing settings, things like that. So they make that configuration into the manager, and that's persisted into the management database. Once the manager gets it, it pushes that configuration down to the central control plane, and then from the central control plane down to the local control plane, where it's what we call realized into the data plane. So we go from a desired state to a realized state through this process of configuration. Also on the transport node is something called the MPA. This is the management plane agent, and this is what communicates to the manager for things like installation of our kernel modules and other coordination of management components. Okay, so I'm going to hand it over to Dimitri, who's going to do a demo, an initial demo, so he'll talk about that.
Okay, yeah, in this session we'll do plenty of live demo. So as Andrew said, I hope everything will go fine, but I'm quite confident. So what I will show you here is just my infrastructure I have in my lab, which is running NSX-T. And as Andrew mentioned, the architecture is very similar to what you are used to with NSX-V. You have a management plane with my NSX manager. I have my control plane with an NSX controller. I should have 3 for high availability, but it's a lab, so I have only 1. And then I have a rack of ESXi servers. And something unique in NSX-T, because it's multi-hypervisor support, I have a rack of KVM. They could be in the same rack, but in my lab I made it a different rack with different IP addresses. And I have a rack of my edge nodes, and if you remember, those are the elements that gives you the routing and especially the north-south communication to go in and out my logical network. And I'll show you that, and since it's the first demo, I'll do something very basic. I'll create just a logical switch in my world, and I will show you how it is represented in the vSphere you know. Okay, so that's the vSphere you know. I have just a couple of hypervisors. That's fine. And that's NSX. That's the NSX-T edition. That's why if you're familiar with NSX-V, it looks a little bit different. But the same concept applies. So you have the management as I said, and you can see that you have very nice graphical and historical statistics on the load of your manager. The same for your controller. And I have all my nodes, so a couple of KVM, a couple of ESX. Here we go. And I will, as I said, show you the creation of a logical switch. So today I just have configured a VLAN to go to the physical world. Let's create a logical network. Let's call it VMworld LS1. And I want that to be an overlay. So logical switch in the overlay. And that's pretty much it. That's how simple it is. Now I can configure a bunch of stuff. Oops, sorry. Under switch. I can configure a bunch of stuff, advanced stuff if I want, such as QoS, port mirroring for operations, spoof guard for security. So a bunch of options are available, advanced options. But if you just want switching, that's it. And this switch is now already available on my KVM and on my ESX. So now I can plug a VM on that NSX logical switch like I would do on a vCenter port group. Okay, this ends the demo, the first demo, and I'll make it bigger with some other services in the follow-up demos. But let's talk now about the services available.
Okay, yeah, so as Dimitri said, we're going to move to the next step, which is talking about what kind of services can we deliver on top of NSX. So as he showed, we can show you logical switching. We have both VLAN backed logical switching as well as overlay backed logical switching, which are really the base feature set of NSX. We also have routing, so we have layer 3 connectivity between logical switches in the virtual world as well as from the virtual world to the physical world. And we have firewalling. And all three of these are distributed features. So when we say distributed, we mean that we leverage the kernel on the hypervisor, either ESX or KVM, to distribute this functionality so that the processing happens locally on that hypervisor in low-cost Intel-based CPUs and doesn't have to hairpin out to like some type of physical routing or switching infrastructure. In addition to that, we also have some centralized features. We have some centralized routing for north-south, so we have to hand off between the virtual world and the physical world, so we centralize that. We support up to 8-way eCMP, so we can have a very redundant, high-performance connectivity, as well as other features like BFD. We also have bridging to physical, so if you have a workload that wants to be layer 2 adjacent to a virtual workload, a physical to virtual connection where they're in the same subnet, we can bridge between the virtual world and the physical world at layer 2. And we also have north-south firewalling for protection of the entire cloud environment. And load balancing in a future release of NSX is something we're investing in. So these are all features that will be centralized on a cluster of edge gateways. So a highly scalable, highly redundant cluster to give you the centralized features, but as much as possible we try to distribute features into the kernel of the hypervisor so you get the benefit of things happening locally in the kernel. So here we'll talk about some different topologies. So a very basic topology is just a logical switch, a layer 2 connectivity between several VMs. Maybe you would add another virtual machine over here, and you might put a routing layer in between. So you can have 2 subnets in a multi-tiered web application, web database application, or something like that. We can also provide NAT services. So if you're running a tool like OpenStack and each of your end users has their own address space environment, we can NAT from their environment out to the rest of the world or NAT between different applications. So this is particularly useful if you're running dev, test, and prod and you have lots and lots of developers with identical copies of an application. They would NAT behind that. Here's an example of the layer 2 bridging. Here we have a logical switch with a router all in the virtual world and then 2 virtual machines. And we're bridging out to a physical machine. So one use case for this is if you have a legacy physical server that you're trying to move from physical to virtual and you need to preserve the IP address, maybe there's a license key tied to it or something like that, you can P2V that server very easily without having to change any IP addressing, get into the virtual world through this mechanism. There are other use cases where maybe for some reason the product's requirement is that it has to be layer 2 adjacent, but it has to maintain a physical presence like it's a mainframe or something like that. We have we continue to support the distributed firewalling feature in NSX-T, similar to NSX for vSphere. So this is where we can put firewall rules at the virtual NIC level of the VM, but not in the VM. So this is what we call the Goldilocks zone. It's the optimal place to put firewalling, but not in the workload where it could be compromised, and not so far away from the workload that it's not as effective from a security perspective. There we go. And then finally, a future feature that we're investing in is a load balancing feature where you can create a pool of virtual machines and you can load balance between them both in a one-arm mode as well as an inline mode, so that you can provide, maybe if you have a dev test production environment, you want dev and test to make sure that every developer has a load balancer so they test their application with load balancing. We've seen customers who didn't do dev test load balancing when they went to the productions, things broke, so now they run the entire CI/CD pipeline with load balancing. And then ultimately all this is driven again by a cloud management platform like OpenStack, or through the NSX API or graphical user interface. Okay, so now we're going to do our next demo, back to Dimitri, in which we'll get a little more sophisticated.
So Andrew talked about a bunch of services we do offer. So in that very same lab I showed you before, I'll deploy this. I will deploy a couple of logical switches and a couple of VMs on each, some VMs on ESX, some VM on KVM, and they will be routed with a distributed logical router, and will go to the external world for north-south capabilities. And I have also some security to prevent some communication between the logical switches, but also within a logical switch. Okay, so that's typical things you may know already from NSX, and I will show you that with this new edition. Before showing you that, I wanted to know in the audience who knows NSX in the audience? Like, okay, pretty much everybody. And who is using NSX in the audience? Okay, and out of the 80% in the audience, how many are doing click, 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 and how many have an automation tool on the top to get your network and security deployed fast?
So click, click, click first.
So click, click, click. So let's go with automation and I'll know the other part. So we have only 5% of people, let's say. So I guess 95% of the others are doing click, 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 which is cool. I love click, click, click too. But in this demo, I could do this topology.
Wait. There, okay.
Yeah. So I could do this topology, creating logical switches like I did with a couple of clicks. I could create my logical router with a couple of clicks as well. And I could create my security with a few clicks as well. But what I want to show you is the power of NSX, which is also one of its big benefits is automation. So for this, I will create this tier 2 application, two-tier application via OpenStack, which is a cloud management system. I could use something else, but I know OpenStack, so I'm using this one. And I'm connecting as a tenant. I'm still connected or kicked out? Yeah, I'm connected in OpenStack, which has nothing to do with NSX. In OpenStack, which is a cloud management system, which is configured to use NSX for network and security services. And in OpenStack, I could create my VMs directly in OpenStack. I could create my networks directly in OpenStack. Networks means logical switches, routers, security, or in OpenStack you have a tool which is Heat, which allows you to do things in batch, in a scripted way. So that's my script, and OpenStack script, and this script, I won't explain what's inside, but it's OpenStack, nothing to do with NSX and VMware, that creates a couple of, what I showed you. So a couple of switches, a router, and so on and so forth. But in a one-click way. Here we go. So in one click, OpenStack is creating this network, and OpenStack is configured in my lab to talk to NSX to do the network and security stuff, to talk to ESX to do the VM stuff on ESX, and to talk to KVM to do the VM stuff on KVM. And if we look at OpenStack, I'm still on OpenStack. They have this network topology in this UI, OpenStack UI, and let's see where it is. It takes like 20 seconds. Oh, it's already done. The 2 switches are created in OpenStack. The 4 VMs are created and plugged like that, and my logical router is connected to the physical world and my 2 logical switches. And you can see in OpenStack, I see a lot OpenStack, no? I don't know. I should say VMware a little bit more, I guess. You can see that in this CMS, I have a couple of ESX, a few VMs on ESX and KVM. Now, if we look at NSX, I didn't do a single click, but you can see my logical switches are here, my 2 logical switches. You can see they have each some, if I click well, some logical switch ports. So 1 port to go to my logical router, a couple of ports to go to my 2 VMs, 1 port for my DHCP, because we offer also DHCP services natively, and 1 port going to my metadata server proxy. It's something OpenStack, I won't explain too much, I won't explain at all what it is, but we do support that as well. And so my 2 switches are here. I have my router, if I refresh, I have my logical router that is created and connecting to my 2 logical switches down and to the physical world up. And I have my security, if I refresh, I have my security that was created in OpenStack. Here we go. That allows SSH and HTTPS. And it was created from OpenStack. I didn't show you this here. It's called security groups in OpenStack. Correct. And I accept SSH and HTTPS. Okay. So again, I'm using OpenStack as a CMS to show you the ability to fully automate things. Now, if like 90+% of you are using NSX today and do click, 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 it's fine. Click, click, click is just fine as well. Okay, this ends up this demo too.
Okay, so again, as Dimitri demoed, what he basically built with that E template is everything on the right-hand side of the screen other than the physical router connectivity. So he was able to build the router, the switches, connect the VMs, and firewall the VMs. And again, we used OpenStack as a demo, but this could be done with click, 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 or it could be in the graphical user interface, or through any other automation tool, whether or not it's an automation tool like Ansible, or Puppet, or Chef, or through another cloud management platform. So these are all possibilities with other tools. So one of the things in this session is an introduction to NSX-T. And what we wanted to do is give you some leads to go to some other really interesting sessions. So the next deeper dive version of this, where you get to understand the routing and switching technology much better, is actually Dimitri again with Francois, and that's on Wednesday, August 30th from 10 to 11. So we highly recommend that you go to that session for the next level of depth in this area. The other session we think would be very valuable to go see is Bruce Davey. He's our CTO. He's also one of the authors of MPLS and one of our top technologists at VMware. And he'll just be talking about the future of where NSX is going, and this NSX-T platform is going to take us to that future. Okay, so now we're going to talk about network management and operational tools. No cloud networking solution is really valuable without being able to operate it. So it's one thing that it can do some stuff, but you really want to see it be able to be run in a production deployment and production setup. So we offer a number of different functionality to deliver this product in a way that can be run in these production environments, ranging from visibility, statistics, as well as things like upgrades and backup and restore, which are all sort of table stakes to play the game. A nice analogy or allusion here in Las Vegas, that you need to run a tool like this. So we'll have another demo about this kind of thing in a second, but let's talk about like some examples of what you can do. We have traffic captures and port mirroring, so you can actually capture traffic for debugging and troubleshooting, or mirror traffic to another port or off of the system over GRE. We have a logical to physical view of traffic paths. The screenshot on the right is an example of that trace flow feature. We have a search tool to quickly find information about topologies through metadata key value pair tags. And we have in-depth logging as well as integrations to things like Log Insight, so that all the logging information comes out of NSX and can be then discovered and mined in those logging systems. We also have content packs to make that easier in tools like Log Insight. So we'll go back to Dimitri, and we'll do another demo here.
Okay. So still using the same lab I used before. I will use this lab to show you all the capability, not all, but a bunch of capabilities we have natively in this NSX edition to help you to do your work. So I don't know, how many of you are in the operation? Like a 20%. So I guess all the others are more in the design and architect. Okay. So let's go with, so I'll talk to the 20% of the audience, because I get the architect usually they don't care. So that's my lab, I didn't touch it. And as an operator, or I'm not, or I was a long time ago, I'm old. It was, when you go into the virtual world, it's always, the first thing which is hard is to find where is what. And that's nothing to do with network, actually. It's true also for compute, for vCenter. If somebody calls you and say, hey, my VM1 cannot talk to my VM2, and it's not physical servers, but it's VMs, and on the top of it, it's using vCenter, then stuff can move with DRS, vMotion, and it's pretty hard to find where is what, and you already lose a few minutes, if not more, to start your investigation with the location of things. So we help tremendously on this, but I forgot to mention something else before. Before troubleshooting, you want also to do monitoring to be sure that everything is running smoothly and you give nice reports to your boss on how much traffic you have. And in this NSX edition, we thought from start how to help you to do your job, management, monitoring, and troubleshooting. So on the management, on everything you have nice built-in statistics. So like on this switch, you can see globally on the switch how much traffic you have globally on the switch. I don't have much traffic because I just deployed the VMs and didn't do any traffic on them. But you can see how much traffic you have globally on the switch. You can see for a specific VM, a specific logical switch port, but at the end of the day, it's a VM. So you can see for a specific VM how much traffic you also have on that one, and it works on KVM, on VMs running on KVM or ESX. Same thing for the routing, where it could be convenient to know how much traffic is going from south to north. So for this application I deployed, you can see how much traffic you had. So again, not much traffic because I didn't run any. But you have this. Keeping in mind our logical router is distributed, as you remember from Andrew. So this logical router is not physically in one place. So those statistics are the aggregation of all of this logical router distributed everywhere. Now, if you want to know for a specific node, you have also the ability to, if I click here, to see this logical router, how much traffic was on this node, on that node, on that node. Okay? That's for the monitoring. Now for the troubleshooting, back to what I said 2 minutes ago, it's pretty hard to know where is what. So for that, we gave you a tool, which is port connection tool, and you can simply select the VM of the tenant, like this one, server 1A to server 1B, or 2B, let's say, if I click better. And this, I'm on the manager. This will contact the nodes to know where is what, or the controller, actually, to be accurate. And you know that quickly that this VM is running on KVM2, this KVM2, And this VM is running on ESXi2, and that's in the physical world. And in the logical world, this VM is connected to a switch, to a logical router, to a logical switch to the other VM. So you have the logical view, and when they need to talk, it's actually going straight from KVM2 to ESXi2. And in the physical world, what you see, the traffic encapsulated, because we use an overlay, and the traffic you see in the physical world is from this KVM2 TEP IP to this ESXi2 TEP IP. And you see those two IPs going through the physical world, and you know the communication between them is working because we have a heartbeat for each tunnel, and it's green. If there was something wrong in your fabric, a switch misconfigured or some routing issue, like now they are not in the same subnets, then it would be red. The tunnel would be red. So that's pretty cool. So you can see this quickly. Now, sometimes, if you're an operator, they can call you and say, hey, you know, my VM1 cannot do HTTP to my VM2, and of course, it's always the network guy's fault. And what you have to do in real life, tell me correct me if I'm incorrect. But what you did in the past, you go on the ESX you love, and you check on the VDS, what is the NIC, if the VLAN is well configured, and on the physical top of the rack, Cisco, HP, or Dell, I should say now, to be sure the VLAN is well configured. And if it's well configured, to check the router, to check the firewall, and you have, I don't know, 10 screens on your laptop. And 2 hours later, you figure out, oh, it's a VLAN misconfiguration or a vCenter misconfiguration or router, firewall. But it takes you a long time. And to test, you have to ask the tenant root access of his VM to be able to do the TCP dump or the ping or the wget, whatever. So you need to have access to the VM itself. We have this new tool, or this, not new tool, but this tool, where you can do all this without asking anything to the tenant, to the owner of the VMs of the application. So I'm not using port connection, I'm using trace flow. And I can say, okay, I want from this VM to that VM, I want to do a ping. Okay, trace. And this will take 30 seconds-ish. The manager will really talk to the KVM or ESX, where is this VM, and ask to inject for real, to inject a packet, which is this packet, the ping from this to that. And the hypervisor, KVM ESX, will take it and will send it for real. And if you sniff on each element, you will see it. And you will see it on the fabric as well. Up to the far end, and the hypervisor receiving it will see the ping traffic. And before sending it to the destination VM, we'll stop that and drop it. But it will really go from hypervisor 1 to hypervisor 2. And how does he know it's a fake? Not a fake, it's a real packet, but a test packet because we have a flag. And, but the packet is really sent for real. And you can see at each step, the hypervisor, in my case KVM2 and then later on ESXi2, will process all its functions. So DFW, switching, routing, then it needs to do switching again. It needs to forward it to the other remote hypervisor, ESXi2, do DFW again and send it to the VM. For each of those actions, the element in charge of this specific action will report to the manager, done it, done it, done it, done it. Okay, received and transferred. So you know what happens for each of those. And for instance, and so it was delivered, and you know ping works without asking the tenant, the admin of this application, any access to the VM. But if you try something like, I don't know, HTTP, source port 5000, destination port 80, and you try HTTP, again without asking root access of the VM, the manager will ask the hypervisor to do that, and 30-ish or a little bit less seconds later will show you the report. And you can see it was dropped by a firewall, and it's because, if you remember, I don't accept HTTP, I accept HTTPS and SSH and ping. That's why. But so you know without asking the guy why, and you know it's because of firewall. And now you can ask and the rule ID, blah, blah. And you can ask the guy to open the firewall, or if you're in charge of the security, to open HTTP, if, of course, HTTP is allowed. But you know that quickly in a couple of clicks. Okay? So to summarize, we thought about management and operation from day one, and you have plenty of tools to give you monitoring and also troubleshooting tools.
Okay, so the next area we're going to go full circle kind of back to where we started with the NSX Everywhere slide. So we're going to talk about some NSX-T use cases. So the first one is NSX as an IaaS, so infrastructure as a service. And here NSX sits as one of the three main components in the infrastructure. You have the compute, again ESX or KVM with NSX-T. You have NSX itself, and then some sort of storage, something like vSAN or alternative storage solution. On top of that sits a cloud management platform like OpenStack, which would have a web portal, have its own set of industry standard APIs and CLI tools, which is what Dimitri demoed with the OpenStack integration. But again, it could be any cloud management platform. And on top of that, we layer the DevOps automation layer. So if you were to do CI/CD with something like Jenkins, you could do infrastructure as code and have your code repeatedly and reliably deployed to dev, test, and prod, and then you know at all times exactly what your topology looks like. So it's in a file like that heat template you saw, or some other technology that gives you that automated deployment capability and that repeatability. So NSX is a key component to delivering this IaaS infrastructure, and particularly NSX-T. Now we'll talk about specifically with OpenStack. So we support a number of different OpenStack deployment technologies, I guess, or distributions. We have the open source one, so if you're brave, you can roll your own and go straight from GitHub and do it yourself, though we don't see a lot of customers doing that. We also have VIO, which is VMware's integrated OpenStack. It's a purpose-built OpenStack distribution that's highly oriented towards vSphere and very easy. And it's great for those of you who want a one-stop shop for all VMware products, but you want that OpenStack front end, so you get those common APIs. We have a customer in the audience, I won't call out the company name, but he's told me once that he said, what his developer said is, well, we want AWS style experience, but we want it on this on-prem infrastructure, and so they went with VIO because they had skill set in the VMware platform. We also support Red Hat OpenStack platform, or ROSP, Mirantis, Canonical, and then the HP, Helion, SUSE worlds kind of converging, so I put those in the same place on the slide. We have customers running HP Helion today, and they'll gradually move into running the SUSE distribution. From the hypervisor perspective, NSX-T works on a variety of both hypervisors. We support the Red Hat RHEL-based KVM as well as Canonical's Ubuntu-based KVM, and of course we support VMware's ESX, the latest version being 6.5 and 6.0 U2. So we give you a lot of flexibility in terms of choice of hypervisors for that on-premise deployment. So another big investment area of NSX, and you'll hear about this a lot more tomorrow's keynote and other sessions, is next generation applications. And we want to deliver container networking in a way like we did for VM networking. We want to give you microsegmentation, distributed routing, distributed firewalling, all the feature set you get for VMs, but in the container world. So one of the challenges today is that you don't really get that. You have these individual containers that all go through a sort of a single service container that acts as a NAT and NATs out from the container host. So if you had multiple tenants on the same container host and their containers are right next to each other, they effectively have connectivity to each other. And what we want to do is give you that microsegmentation between those containers. So in this microservices world, there's this idea of these protected containers, and they ramp in and out of this one node. So that's the goal, is to move away from that model and push a distributed switching system into the container host, and then provide NSX management of that distributed system. So in this world, there's often, they call it a CaaS or a PaaS platform, containers as a service or platform as a service. Actually, show of hands, how many of you doing anything with Kubernetes? Okay, a couple. Anybody with Pivotal Cloud Foundry? Okay, back to the Kubernetes. Anybody with OpenShift, Red Hat OpenShift? A couple people, okay. So that's a lot more than last year. Last year we'd ask questions about containers. There were hardly anybody really looking at the container world, but it seems to have picked up quite a bit. So NSX will provide this single network fabric that can handle both VM networking as well as container networking. And the goal is for containers both on-premise as well as containers in a public cloud environment to give you that hybrid cross-cloud experience. One of the things that we give you that you don't get from the out-of-the-box container or the baked-in container feature set with things like Flannel is that we can give you advanced feature set like BGP-based routing and the firewalling functionality. So ultimately, this gives you the ability to secure your workloads in the container world. So a lot of customers early on when they first started with containers, they were doing dev and test, but prod really was a problem. They couldn't do things like HIPAA compliance or PCI compliance because they didn't have that security layer in their containers world. So with NSX-T, we bring this to you today with NSX. So for a deeper dive into containers, we have a number of other sessions that I recommend. Unfortunately, one of them is going on right now during this session, which is the middle one with Yasin and Eve from our team. But all these sessions will be recorded and posted publicly, so you can go back and do a deep dive on Kubernetes networking with NSX-T. But there are some sessions later in the day, so about a half an hour after this one, Sai and Eve Fauser are talking about container networking with NSX-T. So if you're doing any containers stuff, I highly recommend you leave this room and march right over there and go to their session. And then we'll have some other stuff later in the day today, again with Sai on container networking. And the future of container networking. Okay, the other big investment area we're doing with NSX is public cloud management. So the idea here is to be able to bring networking and security services to your workloads that sit in Amazon or Azure or Google Compute. So that you have a single pane of glass of all networking and security throughout your environment, whether or not it's in an on-prem data center or a public cloud data center. So this allows you to, in the first release of this, we're working with Amazon and allows you to manage Amazon native components in the VPC construct. So Amazon subnets and networks and security groups like that. So this is a interesting solution because what we decided to do is deliver NSX as a service. It's called NSX Cloud. So you actually log into an NSX portal to manage these components across multiple public cloud environments. And like the container stuff, there's a much more detail behind this that we would recommend you go check out. So we have several sessions on this. The main one is the one on the right, which is Amol, Timnis, and Percy Wadia are doing a session tomorrow from 5 to 6 on managing Amazon native components with NSX networking and security. The other session I want to recommend that isn't really specifically about that, but about NSX architecture is a very popular session every year with Nimish Desai. He basically will go over reference design, and as part of that, he'll talk about reference design for container-based networking, and that's Wednesday. Okay, so the reason I'm going to wrap up a little earlier to give you guys a chance to ask questions. So, but before we go to questions, where to get started, we have a number of different resources out there where you can try NSX with hands-on labs. You can get trained and certified. There's a number of blogs and community stuff out there as well. And we really would love it if you fill out the survey for, again, myself, Andrew, and Dimitri. Give us your feedback about the session because it's very useful in planning sessions next year. So thank you all. If you have questions, feel free to come on up. There's 2 mics here. We're happy to answer questions. And if you don't want to ask them in the public forum, we'll hang out a little bit afterwards and you can come up and ask. So we'll start over here. Question?
So I got more than one. Are there any labs on NSX-T?
Not in the hands-on labs quite yet. We're still trying to get that done. We hope to have it in the next month or 2.
Okay.
Days. I'm sorry, days.
Oh.
Is there today? It was launched. I'm sorry.
Oh, there is?
That's
I take that back. I did not know it was going to go live today.
Great. Okay. In your firewall for NSX-T, are you using Service Composer? I saw security groups.
Yeah, so that's something, we have a new policy engine that we're working on. It's sort of the evolution of Service Composer. And so yes, we have security groups today, we have security tags, and we're going to expand that to include security policy and policy management.
Okay. The session, the deeper dive session?
Just on the security, just want to highlight. So if you used to do security with Service Composer in an NSX-V, I guess you do create your groups and you make your group based on NSX objects or vCenter objects, like logical switch, like this VM. So this is available today.
Today, yes.
You can keep the same construct. The only thing I wanted to highlight, vCenter is not required with NSX-T edition, but you can use, and we expect people to still use vCenter because of the benefits of vCenter with DRS.
But is there an API plugin so that you go to vCenter to manage NSX-T, or you do it separately?
So a couple things. The NSX-T GUI we decided to make completely standalone from vCenter. So for the people who want that highly vCenter, coupled experience, NSX-V is probably a better solution. So as Dimitri showed you, it's a separate
I'll
GUI.
show, since we have 15 minutes and it's quick answer, and I love demos better than words. So it's optional, but you can link your vCenter to NSX-T. If you do that, then you can consume vCenter object like VM name and things like that. But it's optional. It's not like you must.
And it's also more than one vCenter. Sorry, I didn't mean
And
to
you can have more than one vCenter.
Oh, you can.
We are not tied to one single vCenter.
Okay. So you don't have to use like what they do for NSX-V with cross vCenter. Where you have multiple primary and secondary. It's one NSX.
So vCenter is optional, and you can have multiple of those. And if you do that, you can create your security based on groups and consume this.
And so you got VM name and VM OS.
Yeah,
and
all that stuff.
The only thing we don't have in this demo, but we will have in the version that's coming out shortly, is the policy, which is a separate part of the UI, which gets into the policy that you see in Service Composer today.
Okay. So in the more advanced, deeper dive, is that really just essentially, if you know NSX-V, it's just kind of showing you really how you do it, what the GUI looks like, or is there really other technical?
There's a bunch of changes in the routing. Sorry, I mean, so there's a ton of changes in how we do routing. We have this new concept of a tier 0 and a tier 1 router. We'll go into depth on how that works. So it is valuable if you know V to go to that session, because there's definitely changes that you want to.
Just one extra thing. So I'm old and I've been here for quite a while. So the transition to understand, or not the transition, but to move to NSX-T edition. I mean, if you know already logical networking, because you played with some other product like NSX-V, it's not that hard. If you remember at the beginning in the introduction, you have the management layer, you have the controller layer, and you have the data plane layer. Those components remain the same. Now, inside the box, or inside the platform, because it's not a box, inside the platform there are changes. The way it is done, because we learned from history to make it better. But for you, if you're an operator or even an architect, it doesn't. It's not that hard to move from one to another.
Right. Okay. So I don't know if this is one or two questions, but the NSX-T as a platform do you think is the roadmap to develop NSX-T as a replacement for NSX-V eventually?
We get this question a lot.
Yeah, I'll bet you do.
Okay, so we will continue to have two products called NSX-T and NSX for vSphere. So we call it NSX-V, that's our slang, for some significant amount of time. I believe NSX for vSphere will not end of life any sooner than 2021 at this point in time. So we continue to make investments into both products. We also are working on ways to transition from one product to the other if you would like to move. And the other nice thing is if you buy NSX, you buy a SKU for NSX, you can apply your license to NSX-T or V. Not at the same time, you're not supposed to do that, but if you buy 100 sockets, you can put 50 on V and 50 on T, and if you need to move some back and forth, then you can move them back and forth. So we want to make this as easy as possible. We didn't want to, it's not like you have to go and purchase an upgrade SKU or anything like that.
So, I mean, obviously, the focus on this is one of the focuses is the multi-hypervisor.
Correct, yes.
So if I'm in a VMware vSphere shop and I'm all, ESXi, I see other advantages to T. Are they taking some of those developments and building them in NSX-V? For instance, being able to do containers, so microsegmentation for containers, big deal.
Yeah, so the plan for containers is NSX-T only. So
then that would be a reason to go.
Yes, and same for the public cloud management, the managing native Amazon components,
Right.
or NSX as a service, which we call NSX Cloud, is a T-based functionality. In that case, you don't really see the under the hood part. You get a nice GUI and you manage through the GUI. But so these new emerging technology spaces, we're really focusing on NSX-T. NSX-V, we continue to invest things like improvements for operationals, components, functionality for the firewall, things like that.
Yeah, I mean, some of the security stuff. So.
Yeah, and if you want, you can always request a roadmap for all the nitty-gritty details from your
Isn't there a roadmap session?
I don't. No, not formally.
They are private.
Yeah, they're private.
Yeah.
Okay, so over here we got a question in the back to you.
Maybe to keep some time, saving some time. Yeah, let me start with this OpenStack thing. Like what version is that, the Harjan or the GUI that you shown? Like
The one I was using here was Newton.
Yeah, so we do the latest and one back. So Newton and Okada, or Okada and Mitaka. Depends on the version of NSX you
Yeah, the reason I'm asking, like I was with the IBM and trying something with the Kilo, where we failed to do some of the options there. But the moment he shown that, I mean, that strikes me like, what version is that?
Kilo is no more supported by OpenStack for a while now.
Like it's all like part of the.
So the idea, as Andrew mentioned, is for each release, NSX release, whatever, if it's NSX-V, because we have a plugin for OpenStack on NSX-V, or T, it's to support the current OpenStack and the previous OpenStack.
Yeah, to keep my question there, I mean, are we working along with the Neutron, or is it something like you have a plugin made for the NSX? Because this is
we are well known in the industry, so if you play with Neutron, you'll see a bunch of VMware guys working on Neutron itself, and of course our plugin, but on Neutron itself as well.
I mean, like
we are the number 4 contributor in Neutron in the whole OpenStack.
So let me keep the question simple. So the one that you shown, is it the integration with the Neutron, or is it completely disabling Neutron?
No. It's integration with Neutron. OpenStack talks Neutron. I mean, I was showing the UI horizon of OpenStack talking to Neutron, and Nova for the VMs and whatever, but for the network piece, talking to Neutron. And Neutron is configured with the NSX-T plugin. So it goes to Neutron and Neutron to NSX.
Yeah, the API call made to that manager. Okay, that gives me some answer on that. And coming to this KVM, just like the backend for NSX is distributed switching, the VDS. And is KVM using the Open vSwitch, or?
Yeah.
Yes. Yes.
And on ESX, it's not using VDS or the vCenter VDS. It's using NSX vSwitch inside ESX. So it's another vSwitch, nothing to do with the vCenter vSwitch,
Yeah, the VDS, like, I mean, I'm just trying
it's
to
not VDS on ESX.
So NSX-T is not VDS, but it's also on ESX is not OVS. OVS for KVM, and what we call the NSX-T, well, the name is the NSX vSwitch, but it's a T-specific, NSX-T specifically new code.
There is a little cream flavor. Interesting.
A bit confusing, yeah.
Yeah, so coming to this cloud management platform, right? So you are trying to simplify it, or because the moment we try to talk about the NSX, people think like it's a vSphere model, right? So the moment I brought this NSX-T discussion into the team, like they're a bit confused, like what exactly we are choosing this when compared to this, like.
Well, NSX-T is intended to be agnostic of
hypervisor.
Yeah, well, the idea is agnostic of the workload. If it's a container space workload, if it's an Amazon workload, if it's an ESX workload, if it's a KVM workload, we are open to all those. We want to provide the networking and security.
Okay, great. Yeah, maybe that's one point. And coming to this container networking, you were talking about the maybe peers into the container and give the ability to container can make use of the NSX-T.
Correct.
So is there any logical network about top of that, or is it the simple logical network you are talking about?
It's the same logical networks that the containers connect with those logical
But does it have any special identifier, just like VNIID, and container can make use of it, or?
You should go to the session. It's way more complicated.
Yeah, we can talk about it. The containers are a first-class citizen, and everything you can do on VM, you can do on containers. Which means, because that's what, I don't know if it's still recorded, so I don't know if I can use French or not, but without NSX, I mean, container is quite painful. So not using a French word, for 2 reasons, and that's what I heard from customers. It's visibility, statistics. You have no clue if your stuff is used or not. And the second piece is security. It's an open bar. Communication between your containers is just fully open. Some customers are fine with that, and you don't need NSX. You can run containers without NSX at all. But we solve those 2 issues if those issues are important to you.
Okay, cool. Yeah, I'm actually still with the container with NSX, so we were trying some of them. So maybe that's the reason I'm keep on asking it. And thanks for clarifying.
Okay, cool.
And we had a question, two more
over here,
questions.
sorry.
And
So
then
you guys mentioned the multi-hypervisor support, but you didn't talk about Hyper-V or Azure.
yeah.
So can you talk a little bit about, is that even in the roadmap? Is it?
Yeah, generally in these
Something
public recorded sessions, we don't talk in depth about roadmaps. So you should come either request a roadmap session
Okay.
through an account team or contact me offline, and we can get into more details about that.
But back to the original vision slide at the beginning, we really want to be sure that NSX, that we provide network and security services, whatever on-site, on-premise, or
Yeah,
cloud
they keep saying any
you
cloud
have.
anywhere, but that's a huge chunk of cloud that's
Yeah.
not being.
So we really have this
It
vision.
sounds like it's something you're interested in.
Oh yeah. big
Is it?
time.
Do you want the Hyper-V support, or are you more interested in the
Azure.
Azure stack?
Azure. That's what we see more than Hyper-V now.
We're hearing that a
on-premise.
lot. Yeah. Okay. Thanks. Question.
So is there going to be integration with the VVD and NSX-T? Is it going to replace the NSX-V, or what's going to happen?
We've had some early discussions with the VVD team at VMware, and at some point, though, we're going to have a reference design that includes NSX-T.
All right. And then secondly, can you link the AWS NSX Cloud to your on-prem NSX-T and manage both of them from a single pane of glass, or is that?
That's the general idea. Yeah, through
So-
the single through the.
Okay.
It's complicated. There's the SaaS version of NSX called NSX Cloud, and then there's also an on-prem version of NSX. And so we're still, the first version that we are launching in this VMworld is the SaaS version of NSX called NSX Cloud to manage the Amazon components.
Okay.
Yeah.
Hi.
Okay, question.
Can NSX-V and NSX-T coexist in the same VM?
Yes, it's definitely dependent on how you put them together and how you architect it. In some cases, you can have them communicate over protocol standards. They both speak BGP, for example. Other designs, we've had a customer run a single vCenter, and he preps one cluster with NSX-V and another cluster with NSX-T. And we're using some of this to aid in migration for customers who want to move from one platform to the other. But it's kind of I can't answer it quickly. You should maybe offline we can talk, and we can talk about exactly what you're trying to do, and there are designs that they can coexist and work together. There's also, you can have two separate clouds completely isolated, and of course they coexist, but I think you're interested in some kind of
Thinking like same
interoperability
VM.
between
Yeah, something like that.
So I'll talk to you offline, and we'll talk about your exact design, and
Okay,
there are
sounds good.
a lot of options there. Yeah.
Thank you.
Okay, any other questions?
Last question here.
Okay.
Oh, okay.
Routing. The idea to ask those questions is to see if with the Amazon or even for T or V, you guys are planning to implement a GRE. And why I'm asking that? Example, right now in Amazon, you're going to probably close a VPN to your site. How can I do routing? Because the current edge cannot supporting dynamic routing protocols to IPsec tunnels. So there's any sections or someone that can see what, because example, it's very normal to enterprise, you put your link, your router, you're going to communicate it to another router over a lot of layer 3. So normally you do a GR tunnel and then you can exchange routing protocols. But NXG is not supported yet. So there's any planning even for what is coming?
Yeah, we can't really talk about the futures, but give me your business card or something. I'll get you in touch with our routing guy, and he can give you all the details.
Jerry, I don't. So the idea, you want to be sure that your network you have in Amazon or outside
VPN
can communicate or can be known in the network you have inside.
Yeah.
And the piece I don't understand why you focus on GRE. But what we offer is the ability to have a tunnel, VPN IPsec tunnel, and behind to have the logical router here and your physical router here, or logical routers here if you have NSX in both places. And those can communicate together through this tunnel, but they don't know about this tunnel. And it's transparent, but they have IP connectivity and can exchange routes, BGP or whatever. And that's what we're working on.
But to Dimitri's point, why specifically GRE?
I work for IBM software layer. Okay, so initially, when you are, I have two kind of situations. When the customer put up his router on our network, POP would probably same thing for Amazon.
Yeah.
So, and then I have my NSX Edge.
Yeah.
So I have layer 3 connectivity between the physical routing passing all over internal layer 3 networks for soft lane. It will be same for Amazon. And then I cannot have peering between those guys.
Yeah, okay.
The only way that I can do that is IPsec. But I can do IPsec, but I cannot, example, get over the IPsec tunnel. I cannot get my router inside of my POP, announce routing to Edge, because Edge do not support the routing protocol.
The NSX for vSphere Edge, yeah.
Yeah,
That
so
one, yeah.
the idea is how can I handle this to make more dynamic? Because right now everything is working in static router.
Okay.
But
No,
the idea
it's,
is- the
yeah,
idea is
we are
improve-
addressing this case. Yeah, we are addressing this case.
Is our address?
We are addressing this case to help you to have something in Amazon networks and known in your physical world or in your on-premise.
Okay.
We can do that offline with a paper.
Okay.
Yeah, so we're out of time. Any
We're out
other
of time.
last questions? No? Okay. We'll stick around for a few minutes, and thank you all for those of you who stuck around to the end.
Thank you.